Can you see that fine?
Yeah, we can see that fine.
Okay. Well, hi everyone. I'm Johan. I'm a maintainer of various open source projects, including the grpc-gateway and Improbable's grpc-web. I've contributed to the Go standard library, and I run a blog writing mainly about Go and grpc. I just started working at Buff, where we're thinking about Protobuf so you don't have to. I'm here today to talk to you about APIs. We're going to take a look at the existing standards surrounding API development and usage. We're then going to dive into Protobuf and grpc and talk about what they offer over the existing standards. We're then going to have a little bit of live coding, where we start from nothing and build up to a grpc server and a little client for testing. Along the way, we're going to explore some of the ways that Buff helps make all this easier, safer, and more maintainable in the long term. So what do we mean when we talk about APIs? Generally, we talk about a service exposing some functionality to some clients. There can be many servers backing the service. For example, if you're exposing an API that gets a lot of traffic. An API is a description, a contract, a guarantee that when you send this, I will return data in this shape. This is how we normally think about APIs, but it's often easy to forget other things that also concern APIs, such as compatibility and API evolution. How do we introduce a new field in a response or a request? How do we change the behavior of some API method? How do we do these things with minimal disruption to the user of our API? We'll talk a bit more about this in a bit. So what do we usually use when working with APIs? The de facto standard for API development today is what I like to call JSON/HTTP, and so did Matt actually, which is really great. A lot of people like to call this REST, but REST doesn't actually prescribe the transport encoding. It's just a way to design APIs, which is why I think JSON/HTTP is a better word. You can definitely design RESTful grpc APIs, for example. Basically, JSON being sent over HTTP 1.1, the format that we're all familiar with. It's simple, it's human readable, it's widely supported, it has some types, floats, strings, lists, objects, and null. It's better than XML. So why are we here talking about JSON/HTTP if it's working fine? What's wrong with JSON/HTTP? Let's start with JSON types. JSON numbers are arbitrarily sized integers, right? Should be no problem sending large numbers? Nope. JSON numbers are 64-bit floating point, so you can safely send anything smaller than a 53-bit integer, but good luck beyond that. Strings are fine, but there's no way to send raw bytes. You often end up encoding them with base64 to safely send them inside JSON. What's worse, there's no single source of truth for the API schema when working with JSON. OpenAPI tries to help with this, but it's not used very widely in the industry. And mostly you end up having to read the API documentation and then making the adjustments based on what you're actually seeing from the server. Because how often does the API documentation match the real server's behavior? The JSON itself is not an efficient data transport, resulting in both relatively expensive marshalling and relatively large payloads. Worst of all, because there's no single source of truth, we have no idea about the compatibility guarantees of these APIs. So what can we use instead? Protobuf, obviously. Protobuf started as an internal project within Google and was later open sourced. It's designed with the shortcomings of existing transport encodings in mind. It's fast, it uses a binary format on the wire, it's well typed, it has a large ecosystem surrounding it, and most importantly, it has backwards and forwards compatibility built in. Using Protobuf, as opposed to JSON, requires specifying the API explicitly in the Protobuf file format. Those files are then used to generate the code used by the clients and servers to guarantee the API contract is upheld. It's commonly said that Protobuf has a steep learning curve, and I hope to challenge this today. The most overlooked feature of Protobuf is the backwards and forwards compatibility guarantees. So what do we mean by forwards and backwards compatibility? It essentially means that a server can evolve its schema without worrying about breaking clients, and vice versa. If we evolve a Protobuf schema in a backward compatible way, old clients and servers will keep working. So how do we know what is and isn't a compatible change? The long answer to that question is that you can read a Protobuf spec and the documentation and find exactly what changes are allowed. And the short answer to that question is that you can use buff for that. This command that we're seeing here on the screen checks if your currently checked out code was changed in a compatible way against the local git branch master. And instead of git branch master here, you can use a ton of different formats, but you basically need something to reference against, of course. So what benefits do we gain from evolving our schema in a compatible way? When we can guarantee compatibility between servers and clients, we get a lot of benefits for free. We can keep iterating on the server side without worrying about breaking users. We can release new clients without worrying about taking down our deployments to upgrade them in step, since we know new clients will work with old servers. We formalize the server guarantees and the client's expectations in the schema, and we never have to worry about breaking clients unexpectedly. We also signal to our users that they can keep consuming our APIs safely forever without worrying that we will break them. But Protobuf on its own isn't a replacement for HTTP/JSON. So what do we use Protobuf with? That's where grpc comes in. grpc is an opinionated RPC framework. It also came out of Google and uses Protobuf by default, but can technically be used with any transport encoding, including JSON. If you want to play around with that, I've written a blog post about how to use JSON with grpc, and it's not great. It can essentially be described as Protobuf over HTTP2 with some extras, such as streaming, included. It has gained a lot of traction in the Go community, especially to solve the question of communications between microservices in large-scale deployments. Using HTTP2 can lead to certain efficiency wins, like multiplexing requests over single TCP connections, more efficient headers, etc. Most importantly, though, it adds the missing network communications part to the Protobuf schema. Many of the benefits of grpc can be gained by doing a similar sort of code generation with just a HTTP/1.1 client. And this is the idea behind the Twitch twerp framework. But today, we're going to focus on grpc. So how do we use grpc with Protobuf? Using the Protobuf file that we saw earlier as a starting point, we simply add the service definitions. Here we can see an example of a single return response, aka unary RPC called add_user. We can also see an example of a server-side streaming RPC called list_users. This is a bit contrived. It's not always suitable to use streaming, but you could theoretically use it for something like listing users. You can also see that we added the request and response message types for each of these RPCs. Now, if we generate this file using the grpc generator, we'll get the server and client definitions generated with it. So how can we use buff to work with Protobuf? When we say buff, we're talking about the open source CLI, naturally named buff. We already saw how we can use buff to ensure changes are made in a backwards compatible fashion. It can also do Protobuf file linting, ensuring best practices are applied consistently in your code base. We've also recently added Protobuf file generation, so you can perform basically all of your Protobuf work with buff. The most interesting part of all, though, is putting all of that together and providing a schema registry from which you can pull and push Protobuf modules, finally bringing the Protobuf ecosystem into the 21st century with modern dependency versioning. It's not done yet, but we're working hard on it. Another thing we'd like to eventually do is a Protobuf language server solution for VS Code and other editors, but that's in the future. All right, we've got a basic intro, so let's do some coding. I'm going to switch. We're going to do a little bit of typing on my keyboard. Hopefully that's not going to be too loud. Can you see my VS Code editor? Yeah, okay.
Yeah, we can see fine.
I saw you nodding there. Cool. Okay, so this is just an empty repository. We've just got a license file and a README, and I figure we'd go from scratch here together just to see how we can easily use and build grpc services with a buff today. So the first thing we're going to do is initialize the module. Okay, and then we're going to create a proto directory, and inside proto, we're going to create the proto file. The first thing we'll do here is just define a proto file. So let's also add a little bit of a hierarchy to the proto directory. And we're going to add a user service like the one we saw before. And the way that we like to use Protobuf file hierarchies at Buff, which is covered in our style guide on the website, is that you have a name for the package, which can be several packages deep. And then you version things with a major version. So for example, in this case, we could use v1 beta 1. And if you make like a breaking change to the beta, you can make it beta 2, whatever. We're not going to be that fancy here. We're just going to make it proto users v1. And then we'll create the proto file in there. Okay, and here we have an empty proto file. So we're just going to start by defining the syntax. And because of how we defined the hierarchy, we know what package we want to use as well. So we're going to make that match the file hierarchy that we had, which was users/v1. So it's interesting to note now that the proto folder is the root of our proto tree. So if we wanted to add other packages, we would add them inside of the proto folder. And that's the package. And then an important option when we're working with Go is the Go package option. And we're going to give it the fully qualified path to our import based on the module, of course. And we're going to generate this into the same folder that the proto file is in now. So we'll make that users v1. And then we want the package that's generated to be called users. And that looks like that. So you can see from this now that I'm already planning to generate into the same folder as the proto file. Okay, so there's the package, and then we can start by defining a service. Sorry, let's start with a service, user service, and we'll add an RPC here called add user. And another thing from the Buff style guide is that you should name your types based on the name of the RPC. And we're going to say that returns an add user response. We can do that. So obviously, now that we define those types, we need to add those types as well. And what parameters should we take now? So this is time for some audience participation here. What parameters do you want to see when creating a new user? Let's see if I can actually access the chat here. Ah, there we go. Dog name. Okay, let's do it. So this will be the name of the user's dog. And what we're going to return when we're creating a new user is, of course, a user. And if you're confused now about these numbers, the number ones and the whatever here, you don't, as a user, someone who's new to Protobuf, you can basically, the only thing you need to know about these numbers is that inside of a message, they must not overlap. And also, if you are making changes to your profile, you must not change the numbers. But that's all you really need to know about them. If you want to know a little bit more, you can look into the Protobuf documentation. It describes basically in which order things are marshaled, but it's not that important for day-to-day usage. So you just need to, if we'll add a new field here in a minute, and then you'll see what happens. So we defined the message user here, but we don't have a user message. So let's define a user message as well. And I'm going to take the liberty of saying that the user has an ID. And of course, a user also has a dog name. And that's all all the information we're going to store on the user for now. And I think with that, we should have enough information to start generating things. So normally, when you want to generate a file, at this point, you would start downloading the Proto-C compiler. However, because we are working with Buff today, we're going to download Buff and use Buff instead. But if you're used to working with Proto-C, then it's going to look quite similar. So we're just going to use go-get to get Buff now. That's going to get the latest release, of course. Okay. So this is the thing. Yep. Okay, there we go. we've installed buff, and so we can run buff proc now. And basically, if you're used to using proc, this is a complete drop-in, or almost complete drop-in for proc. You can do everything that you would have wanted to do with proc with buff instead. And instead of having to install proc, you can just use buff. So we're going to use it for generating things. There are a few things that proc does that buff doesn't do, but basically, if you want to do those things, you can come talk to us and we can discuss about implementing those things. We've implemented what we think 99% of users want right now. So when we're generating files with Protobuf, we need to install some generators as well. And so the next thing I'm going to do is install the official Go plugin. And that's called product gen Go. And you'll notice when working with Protobuf generators that they all have the proc-gen prefix. And because the newest proc generator doesn't include the capability to generate grpc code, we're also going to need to install the grpc generator, which is now part of the grpc-go package. Or almost. It hasn't actually been released yet, but you can do this, of course, and it will get the latest master version, I think, probably. So now we have proc-gen go and proc-gen go grpc installed. We can do buff proc, and let's see, go out. And we're going to use paths equals source relative, which is a setting that means that the files will be output relative to the same path that you imported them, which is much easier than not doing it. Trust me, you don't really want to explore the alternative. Just trust me on this. And we're going to use // as the output. And we'll do the same thing for go grpc out. So basically, this dot here after the colon means that this is the path that we want to output the files in. And I'm saying output it in the current directory, which means that when we are importing, which we're going to do now, of course, we're going to import or specify the file from proto users v1 users.proto. It's going to go into the same folder. And there we go, generated straight up. First time. When I was practicing this, I got it wrong every time, so I'm happy that worked out. And you can see, if we look at the generated code here, we have the user's message generated, and so we have the ID and the dog name generated as types on this message. And then there's some accessors here as well, if you want to get the messages, get the fields of the message. And then we have the add user request, of course, and also the add user response. And if we take a quick look at the grpc file, this is where it gets a little bit interesting, because this is where the service that we defined in the proto file, if you remember, this service user service with the grpc add user, it generates an interface. And this is the client interface, so that's not interesting right now. But the service server interface is what we will need our server to implement in order to support the grpc interface that we've just created. So now that we have generated the files, let's take a step back and make a main.go file. And it's going to be package main, of course. And the first thing we're going to do is initialize a logger here. grpc comes with a dirty little package called grpc-log, which we can use to hook into the internal logging of the grpc library, and also as a logger for our own purposes. Let's see, does that import work? Oh, that import didn't work. Okay, so kind of relying on Go imports a little bit here, but we'll just make it work ourselves. Okay, don't know what happened there. Anyway, we're gonna set the logger to be the logger we just created as well. This just means that we get some debug messages when we start our server, which is nice. Then we're going to create a listener. Sorry. And this may seem a little bit weird if you're used to just typing http://listen and serve, but with grpc, you have to create a listener explicitly. We're just going to serve this on port 10,000 on local TCP. And Matt is going to be actually screaming about this because now I'm going to have to do some error handling here. And I haven't defined a run method, so I'm just going to be like, OK, that errored, whatever. Sorry, Matt. We'll define a run method next time. And then next up, we'll create a grpc new server. Here we go. Now it's imports are kicking in. And you can give this options. So grpc cred, custom codec. Custom codec is what you need if you want to use JSON. We're not going to do that today. And then what we're going to do is we're going to import the package that we generated. And if you remember, actually, we can make this. We can import this from here. This package is called users, but I'm going to call it users pd just because we're going to create another package soon and call that users as well. So users pd dot. This is how you register a server implementation to a grpc server. Now you can see the second parameter to this function here is the users service server interface that we looked at before, which is what you need to implement if you want to actually implement the server, so to speak. We haven't created that yet, so I'm just going to make that nil, and obviously that's going to completely panic and turn everything on fire if we run this now. But we're not going to run it as it is. I also want to use grpc reflection, which is going to make testing of the server much easier. And then we'll just add an info log here, serving grpc on, and then we can take the listener dot adder dot string, and then of course what we'll do is serve on the listener. Let's see if it's yeah, if it's not equal to nil, then we can just log fatal error. Okay, so that's, if we run this now, it's going to start a grpc server, and sorry, as soon as we try to make a request to it, it's going to panic, of course, because it's going to try to call nil. So now we'll need to implement this. So let's create a new package here. Call that users. Call it users.go. And as you'll probably have guessed at this point, we're going to create a struct. Let's call it a server. Shit, that's sorry. This is how you create a struct. Sounds like I'm getting nervous. It's okay. And what do we need to store users on the server? Well, we're going to just create an in-memory slice of users. So let's import that package again. Is that error? Oh, yeah, of course. That's our store of users. And because this is a grpc server, and when you write a server like this, you can expect things to be working concurrently. So we're going to need a mutex here as well. And we're going to use not the pointer to the mutex, which just means that all of our functions are going to need to be pointers. Now, the function that we need to implement here, we can go and look it up in the file, like so. And it takes a context, and it takes a request. Let's remove that so we can fit everything on one line here. And so in order to implement the server, we're obviously going to want to store the users. So the first thing we'll want to do here is just mutex.lock, defer s.mutex.unlock, and then Ooh, that's a nice autocomplete. Thanks, go please. Oof. Dog name equals rec.dogname, I believe. Yep. And we need an ID here as well. What are we going to put in here? Well, we're going to just generate an ID. So I'm going to get the UID package, which was this one. And we're going to do must because we don't have time to do any error checking here. Sumi. And of course, this is a string, so we're going to call string on that, which will give us an ID. And then we can, oh, we're going to need to return the user actually. So why don't we use this, take this user outside. Now you want to autocomplete. Okay, and I think that that's almost everything we need. There is a slightly controversial thing going on at the moment in, I think, why the grpc, Protogen grpc hasn't been released yet, which is that in order to implement this, you also need to implement this interface, which you can only do by embedding this. So we're going to have to do this sort of thing. And now we should be able to use the server here. And we're going to need a reference to it, of course. And that import just worked. Perfect. So if we run, let's reset this. Okay, that's allegedly serving on a port 10,000. That just worked suspiciously. Like, this is going a little bit too well, actually. Usually I forget something. Now, in order to actually test the grpc server, you're probably at this point thinking, aha, well, you can't use curl, so how is he actually going to test the server? Well, I'm going to introduce you to a package that I like to use, which is called Evans, which is a, I'll show you. It's a terminal UI that allows you to connect to a grpc server that implements a grpc reflection, and then just it will automatically build up the requests and responses required by just querying the grpc reflection. So if we do help here, we can see these are the commands available to us. Let's do a describe. Oh, okay, look at that. No, let's do service. User service. So it's detected that we have a grpc server that exposes a user service. And okay, that didn't actually do anything interesting. Let's make that one the selected package. Ah, okay, that's what it does. I see. Yeah, that's not interesting. Let's do describe on add user request. Okay, add user request takes a dog name. Nice. Interestingly, we can also call add user, and it will prompt us for the things that we need to add to the request in order to actually make the request. So dog name, in the chat, what do we want to call our dog? First answer, let's go. Cat. Ugh. Thanks, Matt. Okay, we say cat as the dog name, which doesn't make any sense, of course. And what we get back here is the JSON marshaled result that was the response of the reply from the server. So you can see that we have an ID, which was obviously generated using the UID package. And we also have a dog name, which doesn't make any sense. But we can call that again. And this time we can give it a real cat name. Oh, sorry, not the cat name. Let's give it a dog name, Fido, like so. And there's another user created with a dog name of Fido. Now, let's go out of that and let's close that. We have not a lot of time. Okay, so what I want to do now is just show you what buff can do beyond just generation. So we're going to need to create a buff.yaml file here, because we need to specify where the root is. Just check my notes. So this is how we specify where the roots of our proto repository is. And now we can do buff check lint. And buff check lint returns nothing, which is great because I know exactly how to do this sort of thing without causing problems. But if we just name that package users and we save it and we ran the lint, you can see that, aha, files with the package users must be within the directory users relative to the root, but we're in the directory users v1. So indeed, it says that the path of the package should be consistent with the path of the proto file, which is great. Now, another even more interesting part, you know how we were talking about API compatibility the whole time? Buff check breaking is, okay, so the first thing we're going to do is actually commit all of this now that we have something, because we need something to compare to. So we'll just call that whip, and then we can do buff check breaking against input. And that will check the current workspace against master. And of course, because I haven't made any changes, there are indeed no breaking changes. But let's say we change the dog name, the number of the dog name, and you remember me saying don't change the names, then all of a sudden we're going to get a warning here saying that, well, you removed field number 2. It's not complaining about changing the number per se, because what buff detects here is that you removed one field and you added another field, essentially. And it's OK to add fields. So as long as we change that back to 2, no problems. Let's add like an actual user's name. No problem. Backwards compatible change. Buff by default is quite stringent when it comes to these things. So if we change this to username, sorry, no, if we change this to user dog name, so if we change the name, it's going to complain, because when you're marshalling to JSON, which you may be doing, then the JSON name changed when you changed the name. So you can specify what level you want the breaking change detector to be running at. And you can say, I only care about wire breaking changes. And in that case, this would not have been a breaking change, because changing the name in terms of what Protobuf sees, it doesn't matter on the wire. You can keep doing that. We also have levels for source breaking changes. So in this case, it would have been a source breaking change as well, because the field name changed, which means someone who was trying to access that field will no longer be able to do that because you changed the name. So you can tweak that however you want. But essentially what the breaking change detector gives you is the ability to guarantee that you're always evolving the schema in a way that's compatible with the Protobuf promises that you have given to your clients. So you won't ever have to worry about, oh, can we make this change without worrying about breaking like our paying customer number 200 who has given us thousands of dollars per month to use our API. No problem. You can run buff check breaking and it will all be assured for you. Okay, so that was basically the demo. Let me just jump back into the presentation for a few slides. Okay, so what have we learned today? We've learned about the shortcomings of HTTP/JSON. We've learned about Protobuf and gRPC. We've learned to use buff to work with Protobuf, and we've designed a new API from scratch. And as you can see, it took me about 20 minutes to put all this together. I will share another repository that we have, which is an example repository, but you can, this has been recorded, so you can go back through if you want to build your own services based on this. It's not that bad. Okay, thank you. Let's take any questions. Let's see, actually, we have a few questions in the chat already. I can see. Okay. Ooh. Is it wise to put the generated code into the same folder as the Protobuf files? Ah, this is a great question. So I was doing this for the kind of to simplify the demo. But if you wanted to use Protobuf with several different languages, which you may well want to do, because one of the big benefits of Protobuf is that it exists in a lot of different languages, you can, or you will probably generate files into separate language directories. So you would have something like, we can jump back into here. your folder structure might look like something like proto, and then create a folder in here called gen, and then you can create a folder in here called go, and then you could use that as the root. In fact, let's see, I can generate these files into those paths. We'll need to, you would need to update the Go package as well. But if you see now, it's inside of the gen Go folder, we have the same kind of hierarchy. Okay, you got the proto file here, proto directory, proto directory here as well. You probably wouldn't want to do that. So the way to fix that is actually just to jump into the proto directory and generate from in there. But essentially, and then you may have on the same level as a gen, you may have something like JS for your JavaScript files if you're using grpc-web, why not? Or Java if you're using Java, Shutter. Okay, next up. Okay, I can't really speak about PHP. I think that's, PHP has had grpc support for a long time. I think it's one of the officially supported plugins. I think technically a PHP plugin just relies on the C implementation of grpc. So you should be able to use PHP without any problems. If I want to monitor server via Prometheus, should I start server on 2 ports? First for Prometheus metrics and second for grpc? I would say yes, you probably want to put your metrics on a separate port. But it's an interesting question that leads into other scenarios where, for example, if you want to run a grpc-gateway or you want to run a grpc-web translation server, you can actually do those things on the same port. You can, if you're using something like CMux, which is a library that can multiplex requests at the listener level, then you can split things into separate listeners based on incoming request properties. So you can split out the grpc requests, you can split out the normal HTTP requests, you can split out HTTP requests that have a specific header, etc., which is kind of cool if you want to serve everything on one port. But in a lot of deployment scenarios nowadays, it can be quite simple to just serve things on separate ports as well. So that's completely up to you. How would you suggest to expose the limited amount of methods within a service that could be exposed to the outside world? Oh, yeah, this is an interesting question. Basically, you have like an internal service and you only want to support, expose a subset of those to the world. The way that I would say you should do this is by defining a separate service that only exposes the stuff that you want to expose, and then make that service call the first service. So it's a little bit, the reason is because you don't really want to mix internal and external proto contracts. The external proto contract is obviously very important to keep stable and evolve in a stable manner, whereas the internal one may be one that you can control a bit better if you wanted to. So I would say separate those things anyway. And then you also may have different requirements on authentication for the service that is actually exposed to the outside world. Can you explain a little bit more about the must embed unimplemented thing? Yeah, so what is the purpose? The purpose, this is a great question because it will probably confuse a lot of users who are new to grpc today. So if we go back to the users server, so I had to embed this unimplemented users service server. And the reason why embedding this may be a good idea is that now if you add a new method to the users, let's just do that quickly. Let's make this as simple as possible. Oh. So what I've done here is add another method, and the generated file will now contain both adduser and adduser2. But if you go to my service, I haven't actually implemented adduser2. However, the unimplemented user service server that we embedded automatically generates a method for all the methods. So when you embed it, it will kind of be promoted as the method that is being called when someone tries to call adduser2 when your server doesn't actually implement it. So it automatically allows you to be source compatible when your server does not implement the new messages. So the reason why this is a little bit annoying for some users is because they were kind of used to having their server break when you regenerated. it's kind of nice actually, because it's sometimes you don't really want to forget to implement a. So if I had done this, I could run the tests and like, well, unless I add the test for the new method, but I could build this and it wouldn't warn me that I haven't actually implemented this function. So it's a little bit controversial, the question of whether this should be mandatory, but it's in the grpc team's hands. There was an issue. You can voice your support or rejection of the idea on the issue if you like. It is what it is. And that's why that must embed unimplemented thing exists today. Okay, another question. Do we have time for more questions, Alexander? Or
yeah, I mean, if you're happy with it.
Yeah. I mean, yeah. this is fine. Do you have any advice with sharing Protobuf files with share folders and generating those files in folders too? Not entirely sure what you mean by this. Shared folders. Basically, I think the question is, how do you distribute your proto files to all the services that need them? Yeah, so basically, I'm gonna just assume that's the question.
Yeah, like a mono repo for your Protobus. So like if you had multiple folders with shared messages, and I've had issues in the past where basically generating those shared folders and then the import paths for the generated code.
So you're talking about sharing Protobuf messages between different proto files, or sharing different proto messages between Go services or something like that?
Between proto. So if you, for example, in your example, if you had your request messages in a different folder structure, you then generated the code, the import paths don't always work, right? I've had in the past.
Yeah, so that can be a bit messy. I would say generally when you're writing proto files, more is more. It's quite common to want to kind of dry, so to speak. Don't repeat yourself when defining messages. But because proto files are meant to be evolved over time, it can be safer to not share types. Okay, so this is just going to say don't share types because that's not really a solution to a problem. But I want to preface this by saying it's easier if you don't share types between different proto files. You can use certain shared types, for example, the well-known types. I didn't get into this in this example, but the well-known types include things like timestamps and things like that. And those you should absolutely use because they're used within the whole ecosystem. But for example, if you wanted to define a user and you wanted to put that in a separate folder so that several different services could use it, I would say maybe not, because a user might mean a different thing to one service than it does to another service. And you might not know that when you're designing it. But like 6 months down the line, when you're like, ooh, we need to add a property on the user here, but we don't want that property to be in that user here, then all of a sudden, you can't do that in a backwards compatible fashion. So I would say, generally, it's better to keep things separate as much as possible, even if you end up with quite a lot of repeated code. But to your specific problem, where you already have all of these things separated out, so it's much easier if you have everything in the same Protobuf hierarchy to start with. So I would say if you have to separate things out, try and refactor all of your Proto stuff so that you can have it all in one hierarchy, ideally following something like the buff folder, the style guide folder structure, because it makes it very easy to have all the import paths consistent across all of your different files. And another way of making sure that users can use these things and have the proto files be imported consistently is to generate the files in the same repository as you have the proto files. So this is a little bit up for discussion in certain organizations, but I would always say generating the proto files and checking those into your proto repo is a much easier way than the alternative, which may be to generate the files on startup or something like that, or generating the files in each repository, because you may end up with problems around what generator version you're using and so on. So the absolute easiest thing is to not separate things out. But if you want to separate things out, or you have already separated things out, try and keep everything in a single proto hierarchy. following something like the style guide on the Buff website, and generate the files in the same repository, so each message always has a consistent import path. So you would use the go option to specify the exact path that would be used when you were importing it. Does that make sense? Okay, I'm going to continue.
Yeah.
Would you advise using grpc-gateway if you want to access methods from front end and back end services? Okay, I think the question is, if you have a service who wants to expose an API both to the front end, so a browser, and another back-end server, would I advise using the grpc-gateway? And you basically have two alternatives in this scenario. You can either use grpc-web and talk to the front end, or you can use something like the grpc-gateway. And the grpc-gateway allows you to specify more of a classic REST, HTTP/JSON API, if that's what you want. I would say evaluate each one of them. They both have kind of benefits and shortcomings to each. I mean, I'm a little bit partial to the grpc-gateway, of course, because I'm a maintainer, but I've used both for the same, for working with the browser, and they both work. I'm tempted to say grpc-web is getting better now. It's had some attention in the last few years. The grpc-gateway has existed for like 5 years already at this point. So you could say that the grpc-gateway is maybe a little bit more stable, but it also depends on if you want to have the other benefits of a JSON HTTP API, which is, for example, saying to customers that want to use a JSON HTTP API and don't want to use a grpc API, that you also have that available. But if it's only a browser that you control, a browser client that you control, and another backend service that you control, yeah, I would say either or, really. You can evaluate either of them. But the backend client that wants to talk to that server could obviously use pure grpc and wouldn't need to use the grpc-gateway. Okay, do we have any other questions? I think I covered all of them. Cool. All right. Thanks, everyone.
All right. Thank you. I guess closing notes, really. We've got another meetup next month. We haven't really quite put a date in. It's going to be a workshop based off the both the talks. We're going to try and combine the two of them and hopefully not offend either speaker by butchering it too much. And we're also like trying to theme our meetups. So as you may have noticed, today's was around like services and building services and all that kind of stuff. If anyone's got ideas of what they want to, like what kind of theme they want to explore next, like we explored machine learning last month and the month before. Databases could be an interesting one, or security, or whatever else. If you're interested in anything, get in touch with us via either Meetup or Twitter. That's it, really, I think. Thank you, everyone, for speaking. Thank you, everyone, for showing up.
All right.
Thank you. Bye.
Thanks, everyone. See ya.
I got a quick question before everyone is leaving. In the beginning of the meetup, you guys were talking about a Slack group where everyone is in, or at least Johan was in. Is there a possibility to get an invite to that one, to that Slack group?
Do you mean the Buff Slack one or the Gopher Slack?
I'm not sure. I think
so. There's a Gopher Slack one, and I can get an invite link now for everyone if you're not on that. But he also mentioned a specific one as well.
I think both will be great. Yeah, both will be great.
Okay, I think I can help with the first one.
Yeah, I think the Buff one was on the website. I'll have a look at that and make some show notes. Because that Evans package looked quite nice.
Yeah, Evans is a great tool. I've used it a lot, and it saved me also a lot, I would say. And it's great to not having to set up Postman anymore with all the schema definitions and endpoints, and just to just call Evans and call some endpoints. Yeah,
I'd used grp curl. I don't know how you pronounce it. I'll probably butchered that pronunciation, but yeah, that was quite nice. But an actual CLI looks way nicer. I'm going to stop recording, actually. I realize I'm still recording.